Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 20 of the December daily LeetCode challenge. So after today's question, we are about to complete two-thirds of the December daily LeetCode challenge. So around 20 questions are done. We are left with around 11 questions now. So if you're able to maintain till here, once again, big congratulations. And coming to today's question, so this is going to be the first question with the topic of trees. Okay. Till yesterday we were seeing questions on the topic of stack. Okay. Previously also we have seen question on stack, and I think yesterday was the second time that we are getting a question on stack. And again today it is something different. We are starting with trees now, so the probabilities by the end of this year will be with graphs. Let's see, let's hope for the best. So coming to today's question, 2415, reverse odd levels of binary tree. Okay, so one thing is given very clearly, it's a binary tree. What is a binary tree? Tree where each node can have two children. Okay, at max two children. That is what is a binary tree. Okay, now let's see the question. Before that, see how the input is given. So input is given like this. If you are someone new to the coding, let me tell you this. You are seeing this as a list, but it's not a list actually. You are given a root. Okay, root means the root of a tree. Okay, so if you see here, we are given the tree node class. So each node in this tree is going to be a object of this particular class. Okay, they will have these many functions. Okay, value left and right. Okay, as simple as that. So yep, that's how it is. They have represented like this, but in like programmatically, we'll have to think of it like this. Okay, as a tree, as simple as that, right? Now coming to today's question, given the root of a perfect binary tree. Okay, what is a perfect binary tree? They have given the definition also. You can go through that. What it means is that they are in the same level. Okay, so yep, like see, when the tree is balanced, see, especially if you are doing the binary search, you will understand the importance of how much a balanced tree matters. Okay, if the tree is not balanced, your like binary search will not be of much use. It will be a kind of open solution again. Okay, it will not be login. So that's why the reason the perfect binary tree is a concept which you should be knowing if you are solving this kind of questions. Although in this question you are not going to specifically require this to solve the question. Okay, I'm just telling you, know this topic. It's good to have a topic, if especially for a student, if you're learning data structure algorithms, pay attention to these kind of terms because they are sometimes important while solving a question, but not for this. Okay, not for this question. Given the root of a perfect binary tree, reverse the order, that is reverse the node values at each odd level of the tree. Okay, so what we have to do, for example, they are saying, let us say this is the order of the values. Okay, for example, if you see here in the level 1, here it is 3 and 5. Okay, after that, after the conversion it becomes 5 and 3. That is, all the values that are present should be reversed. Okay, if you see here, initially the values are like this. In example, it should be reversed totally. For example, now it will come 18 first, then 29 first, and then 11 and so on. If you see here, that is how it is. Return the root of the reverse tree. A binary tree is perfect if all the parent nodes have two children and all the leaves are at the same level. The level of a node is the number of edges along the path between it and the root node. Okay, so level is basically the, how much far the current node is from the root. Okay, as simple as that. Now I hope this part, if you are clear, you can start solving the question. I will again see you some let me show some more examples. So yep, if you see in this one, see what is happening. See, first of all, for all the odd levels. Okay, for example, in this case 13 and 11, if you see the order, 13 is coming first and then 11 is coming. Now while you reverse it, okay, this, remember, is, yeah, 11 is coming first and then 13 is coming. Okay, exact reversal is happening over the order. Okay, and if you see here, they have given this, basically the examples are small one. I guess that is the reason why they have given this one. Just go through it, we will get the logic of how it works. Okay, and programmatically also we'll see that. Now coming to constraints, it is going to be around 10 power 5. That is the total number of nodes. Okay, no, sorry, the value are going to be 10 power 5. Okay, the max value in each node is going to be 10 power 5, and the number of nodes is going to be around 2 into 10 power 14. Okay, as simple as that, and the tree is perfect. Now coming to solution. So I'm not sure whether you have been following my videos for tree questions or not, because from a long time we have not seen questions on trees. But if you are someone who have, in recent you have subscribed my channel, I'm sure you will not have seen my questions, like my solutions previously for trees. So I will use the same typical approach which I used to do previously. Let me show you how it works. Okay, so yep, I will be using two DFS functions basically. See, you can even try the BFS one, but why BFS is not a good approach, I will tell is, see, the idea is when we have the parent node, okay, it's always best to, go through the child nodes. Okay, as simple as that. But what happens is, let us say while you are doing the BFS solution, you will have to go through all the childs, only then you will be able to go to the next level. Okay, see, I'm talking about levels. You'll have to complete one level, only then you can go to the next level and so on. Okay, so you can do whichever is, preferable to you, but according to me the DFS solution is more, according to me, that is more preferable to me. That's why I'm doing that. Okay, let's see how it works. So first of all, I'm creating a level elements. So it is acting as a dictionary. Okay, I will show you how it looks. So it will look something like this. Okay, as you can see here, for each level, each odd level, it will show me what are the elements present in that level. Okay, in the same order in which they are present. Okay, for example, in the first example, 3 is coming, then 5 is coming. So it will show for the level 1. Okay, the elements are 3 and 5. Okay, 3 comma 5. Okay, it will show the same order in which they are appearing. Okay, from left towards right. That's what the first function will do. Okay, then I'm calling this function here. So how I'm doing that, let me show you that again. Yep. So if you see, I'm passing two parameters. First, the root of the tree, other one is the level. Level is initialized with 0. That is, if you don't pass a value, it will start with 0, right? If the root is none, it will be returned. Okay. Other than that, if the root is odd, okay, if the level, that is, if the level of the root is odd, then what you have to do, you'll have to just append. Okay. You have to go to this particular dictionary. Okay. Go to this particular value, yeah, this particular key. In this key, there will be a there will be a list. Okay, in that list, just go and append root dot val. Okay, because if you see now the order in which it is called, first we are calling the root dot left, and then we are calling the root dot right. Okay, as simple as that. So this will be doing for all the nodes. So for each node, this will be happening, and while you are calling the child nodes, we are always doing a level plus one. Same for the right also, and we are doing a level plus one. Okay, as simple as that. So if you see, since we're doing the left first, okay, for every node, that is even for the root node, we're calling the left node first. For that reason, if you see, the ultimately this, the way it functions, that after, see, I'm printing this part here. Okay, so if you see the print statement, how it looks, it will show you in the exact same order in which the values are present. Okay, for example, 3 and 5 is present, so first 3 will come, and then 5 will come, and so on. Okay, it will be exactly same order. If I can show some big cases, okay, like this, yeah, this, you see, this is the exact order in which the values are present in that particular node. Remember, all of these values need not have the same parent. Okay, they will not have the same parent, but in that level, this is the order in which the values are present. Okay, as simple as that. So for example, just to show you how like it will be, for example, if you see the level 2, remember, this question talks about the odd levels, but just as example, I'm showing the level 2. Level 2, if you see the order in which it is present, see, 8 is coming first, then 13, then 21, then 34. It's exactly the same order in which it will be recording. Okay, I'm only recording the odd levels, I'm not recording the even levels, because they are not needed in this question. Okay, as simple as that. Now, okay, so I'm calling this function, and it will do that part. Okay, now I'm printing it for your purpose. When you segment the solution, just comment the print statement. Otherwise, it will show you like output limit exceeded or something like that. Okay, it will even destroy the space and time complexities also. Okay, like the time and space conversion. Okay, that will also be elevated if you are printing something in a program. Now I'm using the second DFS function. Okay, this function will modify the values. Okay, as simple as that. First one is just to find the values. Second one is to modify the values. Okay, as simple as that. So here I'm calling the second function. In the second function, what I'm doing is exactly same. Here also same thing, rotation and return it, and here also this part is same. I'm calling the left first and then the right. Okay, the left subtree I'm exploring first, then I'm exploring the right subtree. And for while I'm calling the defense function for the subtrees, I'm passing up level of plus one. Okay, whichever is the level for the root, I'm doing a plus one on that. Now this is the only change that is coming. Now what I'm doing here, see, if you see here, what I'm doing in the root dot while I'm appending to this particular thing. Okay, fine. Now what I'm doing, I'm allotting the new value to root dot. What is the new value? I am doing to see, I'm going to this, I am using this mapping. In that mapping, I'm going to this particular key. In that key, I'm doing a pop. If you see how the pop works, see here, see, this is the order in which the values are present. Okay, in the initial tree. But in the modified tree, what we have to do, this value should come first. Okay, then this value should come, and sorry, just a second. Yep. See, the order should be like this. Okay, first this one, then this one, and then this one, so on. Okay, see, currently it is like this. It is going from left towards right, but in the answer, how it should be, it has to be from right towards left. Okay, so this should come first, and then this, and then this, and then this, and so on. Okay, so that's why I'm doing the pop. What does pop will do? Pop will always pop from the last. Okay, that is the last index. Okay, last populated index. It will be popping from that. Remember that. Pop will always happen from the right. Remember that part. So that's why I'm doing a pop. This popped value will be stored here. Okay, it will be stored here. As simple as that. Remember, every element is visited in the same order in which we are doing initially, but only thing is now we are doing the pop. So pop will ensure that which is the last visited value, okay, in that level is now going to the first value that we are visiting in that level. Okay, as simple as that. So after that, I am returning the root, and yeah, that is it. So yeah, I've already submitted the solution, and it works. If you talk about the space and time complexity, let us say if there are n nodes, then the space complexity will be off. And why? Because we are maintaining the all the values of the nodes. Remember, we are maintaining at odd levels only, not at every level. So in real terms, it will not be exactly the number of nodes, we are not showing that, but in terms of the bigger notation, it will be often. And coming to time complexity, if you see here, we are going through each node only once with this function, and with this function again we are going through each of the nodes. Okay, so it will be off and only, but yeah, we are visiting each nodes two times. So yep, and finally we're returning the root. So idea is the root that is given to us, in the same root we are doing the changes and we are returning it. Okay, that is the second thing. You can even talk to your interviewer. Mostly, see, for example, for trees especially, mostly what we'll do is in the same input itself we'll make the changes. But for other data structure, okay, let us say it's array question or string question, we usually don't make the changes in the input itself. Okay, that is one thing. So you can discuss with your interviewer before coding the solution, to explain the approach, draw the diagram, show the approach how it is working. Especially if you're using a default solution, the interviewer will give you a pen and paper, or even like you can have to go to the whiteboard and they will be given a pen. You have to draw and show how it works, which node will whistle first and then which node, and so on. Okay, so I remember the same thing happened in my interview as well. You'll have to see, this function writing is fine, but we'll also have to take your pen and paper, or you have to draw and show how it works, which node will be visited first, and so on. You have to take an example and do the whole thing, like which node will be visited first and how this particular list will be populated and all that. Okay, so you should be clear how this function. Okay, in my way, see, my approach, I'm very clear, because I've always coded like this only. Okay, so I'm very clear what will be happening. But since you are saying this for the first time, please be very mindful of what you are doing, how this function, and so on. Okay, I took very, like I showed you in a very simple way, but yeah, you'll have to understand every bit of it if you want to master this kind of solutions. Okay, as for the trees and graphs, these are something which will help you a lot. Okay, even in your job, this will help you a lot. If you're going to build something great, this is where you will be stuck. If you're not good in this stuff, status structures, you will be stuck. Remember, linked list and this simple strings and all, everyone can do now. But these are the ones which can change. Okay, which can change even the profits of the company, at the same time your career. So these are the ones which are in high demand. You should be knowing everything about them. Okay, trees and graphs, these are the ones. Okay, try and other stuffs are like, yeah, they are good to know. They are not widely implemented. They are implemented in some cases only. They're good to know. I agree with that. But if you want to know something that is widely used, at the same time very much available, like everyone can get to work on this, that is trees and graphs. You should be very much thorough with them. Okay, as simple as that. So yeah, friend, that was all for this particular video. See, I'm directly using this default dictionary as it is, but normally what you have to do is you have to import and then you have to use it. Okay, so LeetCode already imports these kind of libraries for you. Otherwise, you have to go to the collections. That is, you have to write from collections imported default dict. Okay, that you have to do, and then you have to do. So that I'm not doing. Maybe like while I'm posting the solution in the YouTube, I can include that also, that import statement. So yeah, friend, that was all for this particular video. Here we are having two functions, and we are calling those two functions. That is doing the work for us. First function is for gathering all the info. It is gathering all the elements in the odd levels in the same sequence, and the second def function is for changing the value. Okay, as simple as that. Changing the order of the values in the odd levels. Changing the order of the values in the odd levels. Yep. So yeah, and that was all for this solution. If you like this video, if you like the content, if you are getting to learn anything from this channel, please do subscribe. This really gives a lot of motivation for us to continue further. See you tomorrow. Thanks a lot.